Okie dokie, so today we're talking about the Krebs cycle. This is also called the citric acid cycle. I'm going to keep this a little basic. We'll go over main numbers later, but I do want to cover what goes in and what goes out of this cycle and kind of why it happens. It's going to be very similar to the Calvin cycle in photosynthesis, and so hopefully it has some mirroring of that. So remember, we're bringing in the acetyl coenzyme A from the link reaction that came from the pyruvate. So that's going to come in. That's a 2-carbon molecule, because if we remember, from glucose, which is a 6-carbon molecule, this is going to get turned into 2-pyruvate, which, so that means we have two 3-carbon molecules. And then remember, in the link reaction, we got CO2 that came off of it. And so now we have a 2-carbon molecule. So that's when I say this is a 2-carbon molecule, that's where I'm getting 2 carbons from. So this 2-carbon molecule comes in, combines with the oxaloacetate. So kind of like in photosynthesis, when the RuBPH combines with the CO2, same kind of thing. The oxaloacetate, a 4-carbon molecule, is going to combine with the acetyl coenzyme A, which is a 2-carbon molecule, to make a 6-carbon molecule, citrate, in photosynthesis, or citrate in cellular respiration in the Krebs cycle, excuse me. And then we're going to move from citrate, a 6-carbon molecule, to ketoglutarate, which we don't really need to know these names, alpha ketoglutarate. But what we do need to make account of is that, okay, so one NADH is going to come off in a DH, and a CO2 is going to come off, so one CO2. And I'm going to keep tally here of what's coming out, okay? So I've produced one NADH, and I've produced some CO2 as well. So now I'm at this ketoglutarate, this step, so then I'm going to go to the next step, from alpha ketoglutarate to succinate. I don't really know how to say it. But once again, another NADH is going to be made, so I'll put another tally there. ATP is going to come off, so ATP, one of those as well. So I have ATP, and then another carbon dioxide. So I'm just keeping a running total of what's being produced, excuse me, or sorry for not keeping it in frame, of what's being produced from the reaction. So now I'm at succinate. I'm going to produce one FADH, ADH, 2. So I put in an FADH, I get an FADH2 out, so the hydrogen ion got put in, and then another NADH. And that's for one turn of the Krebs cycle. And so that's kind of what's going on. We're taking this, we're getting 2 carbons out. We're getting, did I miss an ATP? Nope. I don't think I did. Nope, didn't miss an ATP. And so we're getting some CO2 out, some NADH out, some FADH out, and so a little bit of ATP out. But what happens is, so remember we have this glucose, so we had 2-pyruvate. And so when we come in, we hack. Okay, ran out of storage on my phone again, but let's pick up where we started. So, okay, glucose, I'm going to get 2 pyruvates out of the glucose because pyruvate's a 3-carbon molecule. And so I'm going to have 2 acetyls, so I'm going to do this entire Krebs cycle twice, so 1 glucose makes 2 turns. And so I'm going to take all my, what I got out of. Okay, so we're going to take everything in here and multiply it by 2. I already did that, but the camera ran out of storage again. And so I'm just going to take all what I got out and multiply it by 2, and these are the products of the Krebs cycle, just using some enzymes and some coenzyme A. Once again, I'm going to reiterate 2 NADH, 2 FADH2, 4 CO2, and 2 ATP. So that's what we're getting out of the Krebs cycle. I hope that was helpful.